Next, we will discuss about Java stacks area. We will discuss briefly about Java stacks area. Java stacks area. So, what Java stacks area is doing in our JVM architecture? What are the responsibilities of Java stacks area? We will discuss now. This Java stacks area is a runtime area. All methods, all the static methods and non-static methods, blocks and constructors, all this logic will be executed in Java stacks area. In this Java stacks area, we can create several threads for executing methods at a time concurrently. And by default, we have seen in this program execution, by default JVM will create two threads. Those two threads are main thread and garbage collector thread. So in this two threads, our main thread is responsible to execute Java methods starts from main method. Here we have seen in Java stacks area, main thread is created. Inside main thread, two stack frames are created. One stack frame is for static block and another stack frame is a main stack frame. This main stack frame, what it is doing? Main stack frame will execute our program from main method. From main method, it will start our execution. Inside main method, whatever the methods you are calling, for those methods, for example, if you call m1 and m2 methods, whatever, if you have in sample class some m1 and m2 methods, you are calling those m1 and m2 methods. So method execution starts from main method, then m1 method will be called. For that m1 method, one stack frame will be created, and for m2 method, one more stack frame will be created. Like that, main thread is responsible to execute Java methods which starts from main method, and also responsible to create objects in heap area. Just now we have seen it has created S1 and S2 objects in our heap area from main thread. If it finds new keyword in any method logic, it will create objects in heap area. Next we will discuss about garbage collector thread. What garbage collector thread will do in our Java stacks area? This garbage collector thread is responsible to destroy the unused objects from heap area. Whatever the objects, for example, S2 is a unused, just you think like here we have S1 and S2 objects. Our S2 object is an unused object. It is not used by any of object or any of method. Then this garbage collector will destroy that unused objects from heap area. And like in C++, in Java we do not have destructors to destroy objects. In C++ we will be having destroys, but in Java we don't have topic like destructors to destroy objects. So in Java stacks area, as each new thread comes into existence, it gets its own PC register. For every single thread, one PC register will be there to monitor that thread. What that thread is doing for execution performance, everything will be monitored by our PC register. And Java stack, the Java stack is composed of stack frames. We have discussed about stack frames. For every method, it will create a stack frame inside main method. Stack frame is a sub-block of a thread. And a stack frame contains the state of one Java method invocation. That is nothing but a stack frame means in main thread sub-block. Sub-block is nothing but a stack frame. That stack frame contains the state which is related to one Java method. Each Java method will be having one stack frame. When we invoke a method or a constructor, a new stack frame will be created. Once this method execution is completed, that stack frame will be destroyed. So I will show you with diagram how this execution will take place. So we will see now. This is my Java stacks area. Java stacks area. And this is my PC registers. And this is my native method stacks. Native method stacks. We will discuss about one by one. I am explaining you once again. Here you understood method area and heap area, total execution process. Now I want to explain in depth about Java stacks area, PC registers and native method stack area. So here we have discussed about, this is about method area and heap area. That's the reason I am explaining. I have explained method area and heap area with Java stacks area and PC registers and native method stack area. Now I want to give clear explanation about these three. So that's the reason I'm explaining you again about Java stacks area, PC registers and native method stacks area. So this is my PC register, this is my Java stacks area and native method stacks. So just assume that I have three threads in my Java stacks area. Third one, thread 2, and thread 3. I am having three threads in my Java stacks area. As we have discussed, Java stacks area consists of threads, and by default in Java stacks area we have main thread and garbage collector thread. We have discussed that, and that too we can create so many threads in our Java stacks area. So now I have created three threads in Java stacks area. Here I want to explain you the execution process of our class inside JVM in our computer. That's the reason, just understand the concept. About threads we will learn in our multi-threading concepts. So I have three threads in my Java stacks area, and these three threads will be monitoring by my PC registers. As we have already discussed, PC register will monitor our threads. This is my thread 1. This is my thread 2. And this is my thread 3. All these three threads is monitoring by my PC registers. And my each thread is having some stack frames. Stack frames are nothing but a method execution in our Java stacks area. And my thread 2 will also have 3 stack frames. Means my thread 2 contains 3 method executions from my class. And my thread 3 also contains 2 methods. These are stack frames. So here I have created 3 threads in my Java stacks area. All these 3 threads is having stack frames. Stack frame is nothing but a method or constructor execution which is having logic. For one method, it will create one stack frame. For each method, it will create one stack frame in our Java stacks area in each thread. Each thread consists of multiple stack frames. So here I have three threads. Thread 1 consists of three stack frames. That means thread 1 is executing three method or constructor logic. And thread 2 is having three stack frames. That means it is executing three methods or constructor logic. And thread 3 is having two stack frames. It is executing two methods and or constructors logic. And I'm having PC registers. Inside PC registers, I have three PC register objects which is monitoring my all three threads. I have three PC registers to monitor all those three threads. So just assume that this thread 3 stack frame, this thread 3 stack frame is a native method. Thread 3. This thread 3 stack frame. Stack frame is nothing but a method execution. Means my thread 3 is having a native method which is not in Java. It is in some other language like C language. We will see how execution takes place. This is how threads will be created inside Java and it will monitor in PC registers. After each method execution, that stack frame will be destroyed. Means, for example, I have thread 2. In thread 2, one method is executing, that is stack frame 1. After execution of this stack frame means method execution, this will be destroyed. Then control goes to next method execution or stack frame. After this execution completed, this will be destroyed. Same thing will be happen for all these methods. So this is how Java stacks area will work with PC registers and native method stacks. So as each new thread comes into existence, it gets its own PC register. For every thread, one PC register will be there to monitor that thread. So this diagram is showing a snapshot of a virtual machine. This is nothing but a virtual machine instance in which three threads are executing. In these three threads, thread 1 and thread 2 are executing Java methods. That's the reason its execution is done in Java stacks. And the thread 3, this thread 3 is executing a native method. Native method is nothing but it's a method which has written in native to that operating system like C language in Windows. And inside a thread, for example, I have a thread 1. Inside a thread, if there is no sufficient memory for creating new stack frame for execution of a method, then JVM will throw exception like stack overflow exception. It will throw stack overflow exception. This is how Java stacks area works inside our JVM with PC registers and native method stacks. Next we will discuss about this PC registers clearly. What this PC register is doing in our JVM, we will learn it clearly. PC registers. PC register nothing but program counter registers area. So what this program counter registers, PC registers area is doing in our Java JVM runtime area. This program counter registers area, PC registers area, this PC register, I will show you in this. In this PC registers area is a separate program counter register. In this This is a separate program counter register is created for every thread. It is used for tracking the execution in this thread by storing its instruction address. This PC register will store the thread instruction address, and this PC register is created when new thread is created. After thread execution is completed, this will be destroyed automatically. I will make a note about these points. In this runtime area, a separate program counter register is created for every thread, and it is used for tracking execution in this thread by storing its instruction address. And next point, PC register is created when new thread is created. After thread execution is completed, it is destroyed automatically. So this is about PC registers working process. Diagrammatically, we have seen here itself about PC register. That's the reason I am not explaining with diagram, but I am writing the points whatever we have discussed about PC registers. Next, we will discuss about this native method stacks. Native method stacks area. So what this native method stacks area is doing in our JVM runtime process. This native method stack area is responsible to execute all the native methods. Native methods are nothing but a native method is written in some other language such as C or C++ or assembly and compiled to the native machine code of a particular processor. And to create this native method, we must place native keyword in its prototype. I will show you how to create, and it should not have body because a Java program interacts with the host OS by invoking native methods. We will see how we can create native methods. First, I will make a note about this. So in native methods stack area, all native methods are executed. In Java, there are two kinds of methods. What are they? We have Java methods and native methods. First, we will discuss about Java methods. We already know Java methods. It is written in Java language, compiled to bytecode and stored in .class files. These are Java methods. What are native methods? Native methods, it is written in some other language such as like C, C++, and compiled to the native machine code of a particular processor. This is about Java methods and native methods. So, to create native methods, we must place native keyword in its prototype, and it should not have body. A Java program interacts with the host OS by invoking native methods. This is about our native methods and execution of native methods stacks area. This native methods will be executed inside native methods stack area. So I will show you how to create native methods in our Java class. For example, I have a class example. In this class, I want to create a native method. How you will create? Public static. Here you have to use native keyword. Native some int add method. This is my native method, and native method should not have body. Native method should not have body. That's the reason I am not giving any body for my native methods. I am just giving parameters int x and int y. Because a Java program interacts with the host OS by invoking these native methods. How you will call this native methods? Just create main method, public static void main string array args. Inside main method, just call add, send two arguments to this add method, because my add method is having two parameters, int x and int y. I want to send 10 comma some 30. This is how we can create native methods in our Java class. This is our native method in Java class. This is a native method. So this is about all the runtime areas discussion. We learned all the runtime areas in depth with programmatically and with theoretically. If you have any doubts in this internals of JVM, just message me. I will reply you within 24 hours. Thank you for giving your time to explain all this, because I want to explain everything. That's the reason I'm explaining all these internals also, because my students should learn everything from internal and from basic to internal and expert level. That's the reason by taking this much time I'm explaining all those. Please don't mind if I'm wasting your time, because I want you to become expert in all levels. That's the reason I'm explaining in-depth programming with internals, internally what is happening and how execution takes place. All those I'm explaining. Thank you very much.